This says a chemical reaction takes place inside a flask submerged in a water bath. The water bath contains 3.50 kilograms of water at 25.5 degrees C. During the reaction, 61.1 kilojoules of heat flows out of the bath and into the flask. Calculate the new temperature of the water bath. So essentially what we have is we have a water bath, and inside of the water bath we have some kind of reaction flask. And the reaction inside of this flask is endothermic. So heat flows from the water bath into the flask. So the temperature of the water has to decrease, because if the heat flows out of the water must get colder. So in a previous video attached to this playlist, I talk more extensively about these equations and define the variables and things like this. But the equation that is going to be relevant here is Q, heat, in joules, equals mass in grams, specific heat capacity in joules per gram, K or C, times delta T, the change in temperature. In this particular case, we're trying to find delta T because we want to know the new temperature of this water. So we have to divide by M and C sub S, and what we find is delta T equals Q over M times C sub S. But notice that your constant's in joules per gram K, so Q has to be in joules. So we need to convert this 61.1 kilojoules to joules, which we do by multiplying by 1,000, and we get 61100 joules. I'm just going to put a line here so we remember that's the significant figure. Divided by the mass needs to be in grams. Notice the constant's per gram. Gram to the minus 1 meters per gram. So we have to turn the 3.5 kilograms into 3,500 multiplied by 1,000, 3,500 grams. This is 3 sig figs, so I'm just going to put a line there so I remember which one are the significant figures, times C sub S, which we can plug in directly, 4.18 joules per gram degrees C, or K. In this case, my other temperature is given in Celsius, so I'm just going to leave this in Celsius. In a couple other videos, I explain how the change in temperature of Celsius and K are the same, because it is a change in temperature, and 1 Celsius and 1 K are equal amounts. When I do this, I get 4.1 7635, and some more numbers, degrees C. And I just want to put a line there because 3 sig figs, 3 sig figs, 3 sig figs, so that's my significant figures. Now I need to find the final temperature. Well, if this water started at 25.5 degrees and it went down, it had to decrease, right, because heat flowed out of the water bath and into the flask, we have to subtract this. So if we take 25.5 degrees C, subtract 4.17635 degrees C, notice that here we have 1 decimal place, here we have lots of decimal places, but 2 that are significant, so our answer is going to have 1 decimal place, and when we do this, we get 21.3 degrees Celsius for our change in temperature. For our final temperature of the water bath after the reaction and heat has flown out of the water and into the flask.